Hi, let us now learn about curves. I'm sure you have traveled on roads like these. These are curved roads. In mathematics, when we talk about curves, all you have to do is to take your pencil and create a continuous path without lifting your pencil. This is called a curve. There are many types of curves that you can draw. You can draw curves that come back to the starting point. You can draw curves that cross themselves. Even straight lines are called curves in mathematics. If you notice these curves, this fellow, the starting point was this, the ending point is that. You have a different start point and a different end point. Such curves are called open curves. All of these are open curves. But if you look at this one, the start point and the end point, they are the same. The curve comes back to the starting point. This kind of a curve is called a closed curve. So what is a closed curve? A closed curve, the curve comes back to the starting point. Here are other examples of closed curves. You can see that this is definitely coming back. What about that one? You can go around and you can come back, right? So all these are closed curves, all these are open curves. So you can categorize curves as open or closed depending on whether they are coming back to the starting point or the starting and ending points are different. But there's another way to think about curves. You can also look at the fact that this curve is intersecting itself. This curve is not intersecting itself. So we can categorize curves by whether they are intersecting themselves or not. So that is the second way to think about curves. So these are all curves that do not cross themselves. So look at this. This curve is not crossing itself. This curve is crossing itself. This is called non-simple curve. These curves are called simple curves. Now notice this curve is coming back to the starting point. It is a closed curve, but it is not crossing. So this is a closed curve, but it is a simple curve. Same way, this is a closed curve, but it is a simple curve. This is also coming back to the starting point. So this is a closed curve, but it is a non-simple curve because it is intersecting. So you can have intersecting curves that we will call as non-simple, non-intersecting curves that we will call as simple. So if you're not intersecting, not crossing, we call them simple. Now there are two categories, right? We can say open or closed, simple or non-simple. We can combine them. Simple open, simple and closed, non-simple open, non-simple closed. Let us take these curves and group them accordingly. So these curves are simple and open. See, they are open. You can see that the endpoints are different. And they are simple, no crisscrossing. These are all simple and closed. Their starting and ending points are the same. So they are closed. But they are also simple because there is no crisscross. These curves here are non-simple. There is crisscross. But these are open. Look at this. This is the starting point and that is the ending point. So this curve is basically an open curve, but it is crisscrossing. So it is open and non-simple. Similarly, this is open, right, and non-simple. These curves are closed curves. You can see that they are closed curves, right? You can see that they are closed curves. But they are also intersecting. So therefore, they are non-simple closed curves. So I hope the categories open, closed, simple, non-simple you have understood clearly. When we talk about closed curves, when you have a closed curve like this, you have an inside part and you have an outside part. A point like A lies in the inside region. So we say A is an interior point. Points like C and D lie outside the curve. So we say that they are exterior. This is the exterior region and C and D are exterior points. What if a point lies on the curve? We call that point as a boundary point. So all points on the curve are called boundary points. If I have a cricket ground, a point like P is inside the ground. A point like Q is exterior, outside. This is an interior point, that is an exterior point. What about points on that curve there? That would be called a boundary point. Remember, you can talk about interior, exterior and boundary only for closed curves. For open curves like this, you cannot talk about interior or exterior points. You can of course talk about points on the curve, but you cannot talk about what is interior and what is exterior. Only for closed curves, you can talk about an inside and outside. So you can talk about interior and exterior points.